Hey guys, I'm Shannon and I'm going to teach you about inverse trig derivatives. So these are the inverse trig derivative functions. For inverse sine, it's 1 over the square root of 1 minus x squared. For inverse cosine, it's negative 1 over the square root of 1 minus x squared. For inverse secant, it's 1 over the absolute value of x times the square root of x squared minus 1. For inverse cosecant, it's negative 1 over the absolute value of x times the square root of x squared minus 1. For inverse tangent, it's 1 over 1 plus x squared. And for inverse cotangent, it's negative 1 over 1 plus x squared. As you can see, all the ones that start with C have negatives in them. So now I'm going to prove how inverse sine equals 1 over the square root of 1 minus x squared. So first, we're going to find the inverse. Right now we have y equals inverse sine x. And to find the inverse, you switch the x and y and you change the inverse trig to non-inverse. So that would be x equals sine y, or you could flip them and say sine y equals x. Now we differentiate what we got from 1. So sine y equals x. You know that the trig derivative for sine is cosine. So cosine y dy over dx, because this is implicit differentiation, equals 1 because the derivative of x equals 1. So now divide cosine y on both sides and you get dy over dx equals 1 over cosine y. So as you can see, the numerator is starting to look the same. Now we need to deal with the denominator, and we would use the Pythagorean identity, which is cosine squared y plus sine squared y equals 1. So I'm going to subtract sine squared y on both sides. So cosine squared y equals 1 minus sine squared y. And then to get rid of the squared, you would square root both sides, and you would get cosine y equals the square root of 1 minus sine squared y. So now in the fourth step, all we have to do is substitute all the information we found before in. So use the thing we got from 2, which is dy over dx equals 1 over cosine y. And from 3, you see what cosine y equals, so substitute that in, and that's 1 over the square root of 1 minus sine squared y. And from 1, it says sine y equals x, which is the same as sine squared y equals x squared, which you can plug in for sine squared y, and you will get 1 over the square root of 1 minus x squared. And that is what we have up here. So now I'm going to do some examples. So number 1, find the derivative of y equals inverse secant times, y equals inverse secant 3x plus 2. And we would use this formula. So all you have to do is look at this as x and plug that in. So y, or dy over dx, equals 1 over 3x plus 2 times the square root of 3x plus 2 squared minus 1. And since this, you have to use chain rule because of the 3x plus 2, so that would be 3. So that would become 3 over 3x plus 2 times the square root of, and I'm going to expand that, which is 9x squared plus 12x plus 4 minus 1. And that would equal 3 over 3x plus 2 times this, which you can simplify to 9x squared plus 12x plus 3 Then you can factor out a 3 in there. So 3x squared plus 4x plus 1. Then you can also factor that. So that would give you 3 times 3x plus 1 and x plus 1. And that is your answer, actually. Okay, so that's how you do that. So example 2, find the derivative of y equals inverse cotangent of sine 2x. So you would use this formula and you would plug sine 2x all into x. So dy over dx equals negative 1 over 1 plus sine 2x sine 2x. Yeah. And then that, you also need to find the derivative of sine 2x. By chain rule, that would be cosine 2x. And then you would also need to find the derivative of 2x, which is just 2. So then you would move stuff around and simplify. So negative 2 cosine 2x all over 1 plus sine sine squared 2x. And that is your answer. So thank you for watching this video. I hope you learn more about inverse trig derivatives.